We will wait for 5 more minutes for others to join and then we can start the session. Hello everyone. So I think we can start our session. So can someone confirm if the slides are visible and if I'm audible?
Yeah.
Okay, thanks. So my name is Arpit Bal. So I'm a PhD scholar from Department of Electrical Engineering, IIT Bombay, and I welcome you all to the live session 10. So far we have covered almost all the basics of digital electronics, as well as we have also touched upon a few concepts related to memories, um, So today what we are going to cover is something called as hardware description language and some basics of microprocessor. So let me start this session by introducing what is a hardware description language. So basically, whatever circuits we have designed so far, like the counter or the flip flop, so they can be described using few keywords or behaviorally modeled. Like if you go on counting, like count is equal to count plus 1, so that can behaviorally describe a counter. So this is just one example. Similarly, even for full adder, subtractor, and gate, or gate not gate, everything that is present in digital electronics, it can be um, represented using simple syntax or semantics. So how does it help us? So when we go on designing larger and larger systems, let's say we are planning to design a microprocessor, so we are not going to think in terms of basic gates, we are going to think in terms of logic. So that logic, it can be represented or written in the form of a code that will describe the behavior of the system, or it will describe the hardware. So because of that reason, for designing very complex complicated systems, these hardware description languages were introduced. Okay, so with that basic definition, let us start today's session. Okay, so what does VHDL stand for?
A very high-speed integrated circuits hardware description language.
Correct. So VHDL stands for very high speed integrated circuits hardware description language. Option C is correct. So VHDL is one of the hardware description language. So another one is Verilog. Okay. Okay. So VHDL, it has some syntax that needs to be followed. Okay. Let us say we are given a hardware which is as represented in the right hand side. Okay, and we want to describe, so we don't know the behavior yet. What we only need to describe is which is the input port and what is the output port, right? So input port, so DUT is called as design under test, and input port will have a direction into the design under test, and output port will have a direction away from the design. Okay, so yeah, so I see two answers. Yes, so B are input, P, Q, R are output. Okay, so out of these four options, option C is the correct one. Okay, so let us take a moment and observe how is it declared. So the input or output ports, or whatever ports that are used for communicating with the outside world in VHDL, it is declared using something called as entity. Okay, so to declare an entity, we need to use the keyword called as entity. Okay, then what is the name of that hardware? So in this case, this is DUT. Okay, you can give it any name, so but preferably you give it a name so that it makes clear what is the functionality of that particular design. Okay, then you have to mention is, then port, then you start declaring whatever ports are present. Okay, so ports are something that is used for communicating between the outside world and your design, right? So A, B, P, Q, R, so you just list down the ports, then you tell what is the mode of the port, whether it is input or output. Okay, so after mentioning the mode of the port, the next thing is the data type. Okay, so data type, it can be bit, it can be boolean, it can be anything. Okay, there are several data types that are supported by VHDL, so it is covered in the lecture, you can once go through it. So basically the data type, it can be either scalar or it can be aggregate or it can be something called as user defined. Okay, so scalar, it means that only a single bit, so it can be either bit or boolean. Okay, aggregate refers to a collection of bits. Okay, so when I say collection of bit, so this is actually called as bit vector. Okay, so to declare a bit you can use this method, but to declare a bit vector, what you need to do is, so you could have written it is to in bit underscore vector 0 to, let's say 5, let's say I'm taking 6 bits. Okay, so 0 to 5. Okay, so there is another notation in which you can also write 5 down to 0. Okay, so this actually represents a group of bits. Okay, let's say that your input is going to be a number. Okay, let's say the number is 9. Okay, so 9 cannot be represented in a single bit, right? So in that case we can't use a scalar, we need to use something called as aggregate or bit vector. Okay, so this was the basic introduction to data types, and there is something also called as user defined type. So let's say there is a type called weekdays. Okay, so you can declare the type weekdays is Monday, Tuesday, everything till Friday, right? So VHDL gives you an option to define your own data type. Okay, moving on to the next question. So what is the memory addressing capability of 8085? So this is something related to
64K.
Yeah, correct. So this is something related to the 8085 capability. So this is 64K. 64K is the correct answer. Okay, so the next question is related to VHDL. So what are the applications of VHDL? So we have to figure out what is not the application of VHDL out of the listed options. Can VHDL be used for design verification?
Yeah.
Okay. Can it be used to design synthesis?
Yeah, we are doing synthesis also.
Yeah. Can we model analog systems using VHDL?
No, I think D is the answer.
Correct. So we can do design verification, we can do design synthesis, we can model digital systems, but we cannot model analog systems in VHDL. Okay, but in case of Verilog, so there is a version of Verilog which supports modeling analog systems, that is called as Verilog A. Okay, though it cannot be used for.
Please repeat. Verilog.
Verilog A.
Okay.
So that can be used to model analog systems, like you can model a charge pump or anything, any analog system using Verilog A. But in VHDL that is not possible. Okay. So second thing is, so we know what is modeling a digital systems, right? We just represent it in a functionality wise, like we treat it as a black box, and whatever digital system is given to us, we try to write the equivalent Verilog VHDL code. Okay, so what is design synthesis? So design synthesis refers to actually translating the Verilog code into a gate level representation using actual gates, flip-flops and everything. That is called as design synthesis. Now what is design verification? So design verification means whatever someone has designed. So let's say I have designed a black box which takes two inputs A and B, and it checks whether A and B are equal or not. Okay, if it is equal then it will return 1, if it is not then it will return 0. Okay, so this is my design. Okay, I have designed it, and I say this to my boss that okay, I have designed this, but it needs to be verified that whether it is actually working as it was intended or not, right? So to perform that verification, so we have something called as design verification step. Okay, so design verification takes care of functional verification and timing. Okay, so that actual gates will be having some delays associated with it, right? So design verification will verify whether after the synthesis and after the layout step, whether this design is actually performing what it should perform or not. Okay, so this is also a crucial field that is very popular. So VHDL can be used for that one as well, and we write something called as test benches, okay, to test our um, designs. Okay, so now this is a question related to entity. So which one of the following is not defined by the entity? We saw an example of entity, right, in VHDL. So which one of the following was not defined there? Was direction of any signal defined in entity?
Yes, in and out.
Correct. Name of the signal, was it defined in entity? Yeah, it can be, right? Next thing is declaration of ports. Can it
Yeah,
be?
it is declared. It
Correct.
is declared.
Behavior of the signals?
Behavior is not declared.
Correct. So behavior is the one that is not declared in entity. Okay, so the correct answer is behavior of the signals. So entity specifies the name of the entity, like DUT, as we saw in the previous example, then ports of that entity, and all the information related to that entity, like the input port, output port, the data type of the port that is supported, and and their direction. But the behavior of the signals, it is not defined in the entity. Okay. So now, if a combinational behavior is described using process statement, which signals must be present in the sensitivity list? Can someone answer this? You can give it a try. Okay, regarding this process statement and architecture, so I will show one example. Okay, we will do one uh, small question that will most likely clear the objective of HDL, like how to translate from a given HDL code to a hardware. Okay, so that particular question we will do it at the end. So for now, so what I want to know is, so what should be present in the sensitivity list? So you must have seen in architecture declaration we have a process statement, and in the process statement we have a few key terms in the bracket, right? So what are those terms? Can anyone guess? Okay, then we will return to this question after doing that tutorial. Okay, question number 6. Which of the following is a 16-bit microprocessor?
8086.
Correct. Okay, so the next question is related to the difference between microcontroller and a microprocessor. So which of the following statement is true? Does microprocessor have memory?
No.
Okay. Does microcontroller have memory?
Yeah.
Okay, so it means B can't be correct, and A and D are similar because both of them have memory. So option C is correct. Question number 8, right? So microcontroller, they contain a memory to store program and data, and this is what distinguishes a microcontroller from a microprocessor, right? So option C is the correct option. So 8085 microprocessor can operate with dash
3 megahertz
correct.
clock frequency.
Yeah. So these are related to the capabilities of 8085 microprocessor. So these are given in the lecture notes, so you can go through them. Okay, then question number 10. So which of the following statement is true related to assembly and machine language?
D.
Both are machine independent. No. Okay, so let me define what do you mean by machine independent and machine dependent. So does their syntax or does the keywords that are used, do they change from machine to machine, or are they same for every machine? So if they are they change, correct. So it should be machine dependent, right? So option C is correct, because let's say you have designed one microprocessor on your own and you are using a different set of let's say mnemonics or keywords. So accordingly the assembly language that needs to be used will also change, right? So that's why it is machine dependent. Okay, then this question is related to 3-cycle instruction execution. Okay, so which of the following cycle is not present in the 3-cycle instruction execution model?
Encode.
Correct. Okay, so in a microprocessor, what happens is, first the instruction is fetched from the instruction memory. Okay, next whatever instruction is fetched, let's say I have fetched an instruction 101101. Okay, this instruction doesn't make any sense unless it is decoded, right? So each bit will be representing something that will pass through a decoder, which is called as an instruction decoder. This instruction decoder will give out several control signals to other hardware that is present. Okay, and this decoder performs the decoding action in a phase called as decode. Okay, and after the control signals are released from the decoder, so it will direct the respective hardware to perform certain actions, right? It can say that ALU, you add this particular number by let's say +2 or +4 something, right? So that phase in which actual execution of tasks take place, that is called as execute. Okay, and these 3 cycles, they keep on repeating the fetch, decode, execute phase. Okay, so they keep on repeating till all the instructions that are present in the instruction memory, they are completed. Okay, so encode, there is no phase called as encode. So option D is the wrong option, so that is not present. Okay, okay, so now moving on to the next question, that is, so we are given a basic logic block which is described by the following in VHDL code. Okay, so the sensitivity list that we were talking about, so this is the sensitivity list. Okay, so you can observe which variables are placed in the sensitivity list. so when we go back to question number 6, that will be helpful. Okay, so okay, let us try to understand what it is doing. Okay, so we have a begin statement. So we have a if statement, if s is equal to 1. Okay, then the variable z is assigned a, otherwise z is assigned b. So can anyone tell me what is this behavior? So out of all the digital electronics components that we have studied so far, can someone guess which component has this behavior? A, B and C. So there are 3 inputs, right? And 1 output. Can you guess any component? Can it be an
multiplexer?
Correct, it's a multiplexer, right? So multiplexer with 2 inputs and there is a selection. So what is the selection? Out of A, B and S, which one do you think is the selection line? S, correct. Okay. And what is the output? It is Z. Right, because Z is being assigned a variable. Okay. So what should I connect to 0? So when S has a value 0, what should be assigned to the variable Z?
B.
Correct. It should be B because when S is equal to 0, then Z is assigned the value of B. Okay. But when S is equal to 1, Z has to be assigned a value A. Okay. So this is how we translate a given code, the behavior of code, into digital logic. Okay. Is everyone clear how we did the translation? So option B is correct, but what will be the exact translation that we saw in this case? Okay. Does anyone have any doubt in this question? Okay, so moving on to the next question. Okay, so which of the following keyword defines a one-dimensional array with elements of the bit data type? So whatever data types we saw, so can someone answer this? So here we are looking for a one-dimensional array. And each element of that array should be a bit. So it means it's a collection of bits, right? Option C. Okay, bit vector. Yeah. So if it is a collection of bits, then it is a aggregate data type. And aggregation of bits, as I gave an example of, if it has a value 9, right? You need to represent it in bit vector instead of bit. Okay, so question 13, option C is correct. Okay, then what are VHDL and Verilog? So in the very beginning we coined a term.
Hardware description language.
Correct, hardware description language. Okay, so these were the questions for today. So now what I'll do is I'll give one more question that is related to a tutorial. So let me make a new slide. Okay. Let me call this question 15. Okay, then okay, let me put this here. So wherever there is a blank, so something is missing there. Okay, you need to figure out what needs to be placed there. Okay, this I will continue here. Okay, so I'll number these blanks as 1, 2, 3, 4 and 5. Okay, so let us start with 2. Okay, because 2 is the easiest one to figure out. Okay, so what should the process, this particular list, contain? So that is termed as a sensitivity list, right? So let me give a statement, then you need to figure out what should we put in the blank number 2. Okay, so the sensitivity list, it should contain anything that appears on the right hand side of a process. Okay, anything, or if it appears on a comparison, like if there is somewhere any kind of comparison and there is a variable mentioned, then that should be present in the process, the sensitivity list. Okay, so can someone tell me what should I place in 2? Y and S. Okay, is it correct? Should I place Y and S? Okay, can you tell me why should I place S here? Okay, let me write the conditions which needs to be fulfilled so that the variables can be placed in a sensitivity list. Either they appear on RHS of a process statement, or if they appear on a comparison. Yeah, can someone tell me? Okay, so I got one answer as Y and S. Let us see whether Y satisfies that criteria. Does Y appear in the right hand side anywhere? Does it appear here? No. Does it appear here? No. Here, no. So Y does not appear on the right hand side. Does it appear on a comparison part? Here, no.
Yeah.
Here, no. Here, no. Y does not appear either on the comparison or on the right hand side. So Y cannot be placed. Is this clear? Okay. So similarly, can S be placed? So does S appear on the right hand side anywhere in these equations?
No, in the left hand side.
Correct. But does S find a position in the comparison?
Yeah. S is equal
Yeah.
to 0. Comparison is there.
So S will be there in the process statement, this sensitivity list. Okay. Similarly, can anyone tell me what are the other things that should be present in the sensitivity list which satisfies?
X,
Okay.
X temp, it is
Yeah. Okay.
equals to
X
X
temp.
temp.
Similarly, anything else which satisfies either of these criteria? Okay, from the comparison part we have written whatever variables were present there. Can anyone tell me in the right hand side what are the things that are not present in the sensitivity list yet?
A and B?
Yeah, A and B. So A and B should be present here. Okay, A, B, Xtemp and S are the uh, components that should be defined in the sensitivity list. Okay, and what will happen if we don't define a variable in the sensitivity list? The issue is in any form of combinational logic, so you have to mention whatever uh, means whatever satisfies these either of these conditions in the sensitivity list. If not, then they won't be synthesized as per your intention. Okay, so anything that is that satisfies either of these conditions, it should be present in the sensitivity list. Okay, so that means all the signals that are read in the process. Okay, so now we have defined something called as, so A, B are will be defined in the ports. Okay, similarly S, but X temp, it's like a variable. Okay, so it's basically a signal. And where should the signal be defined? Does anyone remember the position? So I'll suggest you to go through the lecture which is related to VHDL. So in VHDL there are specific positions assigned where you need to define the signals. Okay, so in this case the XTMP, it needs to be defined in 1 in this location. Okay, so we have to define signal XTMP is, let us say, bit. Okay, so this needs to be defined at exactly this location. You can't define it anywhere else. Okay, so it should be present before the begin statement and under the architecture block. Okay, so we are done with 1 and 2. Okay, so can anyone guess what should be 3? So I can give one hint. So 3 is like a closing statement. And 3, 4, 5 are all related.
And if?
Yes, correct. So 3 is and if. Similarly, what is 4? End process. Yeah, correct. 4 is end process. What is 5? Okay, correct. This is end architecture. So only end will also do. Okay, so we have filled in the blanks. So now we are going to do one more thing. Okay, so now we have variables a, b, y and x. Okay, so if x is not visible, x is actually present here. Okay, so what I want you to do is, so try telling me what is the direction of these variables. Okay, so assume that these are actually the ports, so these are already defined in the entity, but from this code can you identify whether these are input or output ports? Okay, so what can be a? Can a be input? From this, whatever is given in the process statement, can a be an output? Okay, how to identify whether the given port is input or output? So if anything is present as an output, it should have a variable which is being written to it. It means it should be present on the left hand side. Okay, so is a present anywhere on the left hand side?
No.
Okay, so a cannot be a output.
A and B then input.
Yeah, a and b are input. Similarly, y and x, what can you comment about them?
Y and X both are output.
Okay, y and x both are output. Okay, this was one more exercise. The last exercise that we are going to do is whatever process statement is given to us, okay, and whatever port information that we have, let us try to figure out what hardware it is going to synthesize. Okay, so from an if else statement, from the previous example that we did, so what can we say about this portion? What can this synthesize into?
2 to 1 multiplexer.
Correct. So this will synthesize into a 2 to 1 multiplexer with the selection as
XTEM.
no.
Yes.
Yeah, S. And what should be the output of this multiplexer? XTEM. Correct. So when S is equal to 0, what should be the value that needs to be selected?
A.
Correct. And when S is equal to 1?
B.
Correct. Okay. So this part of the code synthesizes a multiplexer like this. Okay. Moving on to the next part of the code. Okay. So here you also need to take care of this particular logic. If xtemp is equal to 0 and S is equal to 0. Okay, if both are 0, then you need to select y is equal to 1. Okay, so you need to form another multiplexer. Okay, so in this multiplexer, whatever condition is present here, it needs to come as the selection line. Okay, so let us say whatever condition is present here, it is going to give a 0. So it means whenever this condition is true, it will give me a 0. Okay. So xtemp equals to 0 and s is equal to 0. So let me write a small truth table, okay, with xtmp and s. And what should be the output? Output should be y. Okay, let me call this as m. Okay, let me call this output as m. Okay, so when xtmp is 0, s is 0, so m should be selecting 0. For any other value that should take care of my else, it should be 0 1 1 0 1 1. M should be 1. So this is the logic that I want the selection of the second mux to implement. So can anyone tell me what is the hardware that can perform this particular logic? If two inputs are 0, then the output should be 0. If any of the input is 1, then the output should be 1.
OR gate.
Correct. So this is actually an OR gate. Okay. So what I can do is, I have S, I will take X term, I will put a OR gate here, and that OR gate will behave as the selection line to the next mux. And whenever that is 0, I should select 1. Okay, and whenever that is 1, I should select 0. Okay, and this synthesizes our hardware. So last thing that is given to us is x is assigned the value of xtemp. So it means xtemp is nothing but x. Okay, and this is our black box. Right? S is also a port. So okay. Is this question clear?
Yeah.
Does anyone have any doubt in this question? Okay. So this question actually covered the different aspects of VHDL. One is related to the sensitivity list. Another one, how to identify the direction of ports when you are given a certain VHDL code with the process. Second thing, how to translate from a given VHDL code to actual hardware that it is implementing, right? So if let's say you had to mention this hardware somewhere and you have to describe it to a computer, how will you do it? So the best way is to use a hardware description language, and it gives you a form of abstraction, right? So instead of actually writing a mux, you can just write it in the form of a if else statement that will also behaviorally represent a mux, right? So there is another form of architecture which is called as a structural architecture. So in structural architecture, what you can do is you can actually define a mux. Okay, you can write the 3 ports, 3 input ports and 1 output port of the mux, and that will synthesize a mux, right? But you can also represent it in the form of behavioral modeling that will describe the functionality, but it won't tell you directly that it's a mux, right? You have to figure it out from this code. So these things are usually taken care of by the EDA tools, that what needs to be inferred how. Okay, and also we observed that if we are given a particular logic, okay, like this condition, so how to translate that condition into a truth table, and how does that truth table translate into a hardware, right? It could have been anything, but it is visible that it is basically an OR gate. Okay, so this was question 15. Now moving to the question 6 that we skipped. Can anyone tell me the answer of this question number 6? So if a combinational behavior is described using process statement, which signals must be present in the sensitivity list? Option A, correct.
A.
So all the inputs of the combinational logic, it must be present in the sensitivity list. Okay, so these were the questions that I planned for today, and we will give a go through. The first is related to the full form of VHDL. Second question was related to entity declaration. So entity basically describes the uh, ports that are used for interacting with the outside world. Okay, and yeah, so there is one more interesting thing. So whenever you are testing, so as I mentioned, right, there is a process called testing where you write test benches. So what you do is you only have access to these ports A, B, P, Q, R. Okay, so A, B is used for giving the inputs and P, Q, R is observed, right? So if whatever combination of AB, so AB can have four combinations, right? 0 0 0 1 1 0 1 1. So the verification engineer has access to only these values. Okay, and he can make the observation at PQR. He cannot touch anything that is present inside the DUT. Okay, so these four combinations are applied to the DUT, and whatever is the output of the DUT PQR, it is checked whether that output matches something called as a golden output or not. Golden output is the expected correct answer. Okay, so if that matches, then that design is functionally correct. Okay, then the next question was related to the capability of 8085's memory addressing, so that is 64 KB. Then next one was related to which one of the following was not an application of VHDL. It cannot model analog systems. Then regarding the entity, so entity does not define the behavior of the signals. So the behavior is declared in the process statement architecture, right? So then next question is related to the sensitivity list, what it should comprise of, and as we observed in our in that last question tutorial, so it should contain any signals that are used as an input. Okay, and input signals are present on the right hand side of the process statement. So whenever you see a signal on the right hand side, you can comfortably say that is an input. Okay, then another thing that should be present in the sensitivity list is if any variable or any signal, it is present in a comparison, right? So that should also be mentioned in the sensitivity list. Okay, next question was related to 8086 microprocessor, that it's a 16-bit microprocessor. Next was related to difference between microprocessor and microcontroller. Basically, microcontroller contains a memory to store both program as well as data. And next was related to capability of 8085 microprocessor, that it can operate with a 3 MHz clock. Next is related to machine and assembly language, that both of them are actually machine dependent. Okay, then next question is related to execution of an instruction in a 3-cycle instruction execution model. So fetch, decode, execute is the process. Okay, in the next question, what we did is we tried to understand what that hardware is going to be implemented from the given process block of a VHDL code. Okay. Question 13 is related to the data types. So please, so whenever you are planning to start writing a VHDL code, ensure that you are well aware about the data types that are present there, data types that are supported, and so this is a very sensitive part, the data types that you are going to use. So it is possible that what you are actually trying the hardware to infer is not going to be generated only because there is a data type mismatch. Okay, so it means you should know your tools very well before you go to an actual war, right? So that is related to data types. The next is So what are these things called as VHDL and Verilog? So those are hardware description languages. And then we solved a small tutorial that clarifies few concepts related to translating a VHDL code into an equivalent hardware, then sensitivity list, and how to identify input and output ports. Right. So these are the things that we covered in today's session. If anyone has any doubt, then they can let me know. If not, then that's the end of today's tutorial session. So thanks for joining. We can wrap up. Is there any doubt? Okay, thanks. Then we can wrap up this session. So I'll be still present here. So if anyone has any query, then they can let me know. Okay. Thanks everyone for joining. Hello. Uh, Ramadevi, do you want me to go through whatever we have covered today?
Yes, Bhaiya, please.
Okay. So in today's session, what we covered is related to uh, hardware description languages and few basics of microprocessor. Okay, so mostly it was related to hardware description languages. The first question was related to the definition, so the full form of VHDL. Okay, starting with the second question. So second question, so in VHDL we have so what is hardware description language? So it's used for describing any hardware. Let's say you have a full adder or a summer. So instead of actually representing the gates, what you can do is you can describe them based on their functionality, right? So that is called as a hardware description languages. And what is the benefit of using a hardware description language? So let's say you are planning to design a very complicated system. Okay, let's say a microprocessor. Okay, so in that case you can't think it in terms of few gates or something, right? It will be very complicated. So what we do is we describe the behavior of the microprocessor and we give it to a EDA tool. So the EDA tool's responsibility is to convert that hardware description language, whatever code that we have written, into equivalent gates, right? So it uses the library, whatever gates are available already in the library, and it maps it to perform the similar function. Okay, so VHDL is one of the hardware description language, and let's say you are given a system in which you know the ports, you know the output and input ports. So one of the key things that needs to be kept in mind in VHDL is the entity declaration. So entity declaration takes care of the input and output ports in VHDL. Okay, so in this question what we were supposed to figure out is which one is the input port and which one is the output port, right? So this is how you are supposed to declare an entity in a VHDL. Okay, so for finding out the input port, what you need to see is the direction of the arrows. So if the direction are towards the DUT or design under test, then it is an input port. If it is away, then it is an output port, right? So option C is the correct one in question 2. Question 3 was related to the memory addressing capability of 8085. So 8085 can address 64K of memory. Next question was related to the application of VHDL. So VHDL cannot be used for modeling analog systems, but it can be used for modeling digital systems, performing design verification and design synthesis. So what is design verification? Let's say you have a digital design which is given to you. Okay, you check the functionality that okay, whether this system is performing as it was intended to do or not. So that is a verification process. Design synthesis means whatever code you have written, translating that into gate level netlist. Okay, that is called as design synthesis. So for all this, VHDL can be used except for modeling analog systems. Okay. Then in an entity, what are the things that are defined in VHDL? So one thing that is defined is the direction of any signal. Okay, let me go to this question. So in this entity, the direction of signal, whether it is input or output, that is declared. The list of signals, that is also declared, right? And also the data type. So bit is a data type. Okay. So A is declared, B is declared, name of the signal, and declaration of the ports, that is declared. But what is not declared is what is the function that it is performing, right? So the behavior of the signals is not declared in the entity. Okay, so question number 6, we will move to it after the last question, so that will make a bit clear. So the next question was related to which one of the following is a 16-bit microprocessor. 8086 is the answer. Next question was related to what is the difference between microcontroller and microprocessor. So microcontroller basically has a memory to store the program and data, which is not present in a microprocessor. Okay. So 8085, it can operate with 3 megahertz clock. So this is related to the capabilities of 8085 microprocessor. Next is related to machine language and assembly language. So both of them are actually machine dependent. So from machine to machine they are going to vary. Next question is related to the instruction execution model, the 3-cycle model. So the 3-cycle model has fetch, decode and execute, but there is no encode option. In the fetch cycle, the instruction is taken. In the decode cycle, whatever instruction is present, it passes through an instruction decoder, which after decoding whatever instruction is present, it sends out the control signals for different digital elements, right? So the different control signals are responsible for controlling actions like enabling a register or performing an arithmetic operation. Okay, so that actual operation is performed in the execute cycle. Okay, and these 3 cycles, they keep on repeating as long as all the instructions that are present is not completed, right? But there is no such thing called as an encode cycle. In question 12, what we did is we are given a small snippet, code snippet of VHDL, and we need to understand what that is going to synthesize into. Okay, so whenever there is an if then else statement, if else or if then else, so you have to understand that it is going to synthesize into a mux multiplexer, right? And whatever is present in the ifs condition, that is going to be your selection line. Okay, so if s is equal to 1, select a. This is what the first statement says, and the output is going to be z, right? But if there is any other case, so in any other case in a mux is actually 0, right? So for 0 you attach b. Is this question clear?
Yes, Bhaiya.
Okay. So similarly, so any VHDL code, any complicated VHDL code, so it at the end of the day it will boil down to simple digital logics, whatever we have studied, AND gate, OR gate, multiplexer, or even a sequential circuit. Okay, then this question is related to the data types that are supported by VHDL, and this question asks that what is the keyword that defines a one-dimensional array with elements of the bit data type. It means it is an array actually of one dimension, and each element is actually a bit. Okay, so the collection of bit is actually a bit vector. This keyword is used. Okay, so this is already covered in the lecture. Okay, and VHDL and Verilog are the hardware description languages. So after that we did a small tutorial. So in this tutorial what we saw is how to identify the signals that finds its position in the process sensitivity list of the process block. So sensitivity list is actually the list that is attached with the process statement. Okay, and what are the type of signals that you need to place in the sensitivity list? So these are the two conditions. So if the signal satisfies either of condition 1 or condition 2, then it must be placed in the sensitivity list. So what is condition 1? Condition 1 says that if the signal appears on the right hand side of a process, then it has to be placed in the sensitivity list. Second thing, if the signal finds a place in the comparison anywhere, then also it needs to be included in the sensitivity list. Okay, So we can observe that A, B are present on the right hand side of the equation in a process statement. So A, B should be present in this sensitivity list, right? Similarly, in the comparison part, we can see that S and X temp both are present in the comparison. So these two also needs to be included in the sensitivity list. Okay. Is this clear?
Yes, Bhaiya, sensitivity list and netlist both are same.
No. Sensitivity list is different from net list. So net list is basically representing your combination of gates, multiplexers and everything. Okay. But sensitivity list is actually a list that is attached to the process block, which takes care of all the things that needs to be monitored when this particular code is being executed.
Okay, Bhaiya, got it.
Okay. Yeah. So similarly, how we did question number 12, right? So we inferred that it is going to be a multiplexer and what will be the input and output. Same thing can be done here as well. Okay. So here we see an if-else statement, and whatever is present in the condition block, that will be the selection line. So okay, so this is a bit messy, but if you can see,
Same as 2 cross 1 mux.
correct, this will be a 2 cross 1 mux, and if S is equal to 0, then A will be selected, and if S is equal to 1, then B will be selected, and the output we call it XTMP. Okay. For the second condition, what we do is we say that okay, if XTMP and S0 and S, if both are 0, then what I will do is I'll define a signal called M. Okay. So in that case M will be 0, for any other case M will be 1. Okay, then we drew a truth table. Okay, and can you guess which circuit has this behavior? That if two inputs are 0, then only it's
OR
up.
gate.
Correct. So if we use an OR gate and we connect it to another multiplexer, okay, so there is another if statement, right? So this if statement will give rise to another multiplexer. Okay, and if that statement is executed, if this we are defining it as 0, so if that is 0, then y is equal to 1 will be selected. If it is anything else, it means if it is 1, then y is equal to 0 will be selected, and the output here is y. Okay, is this clear?
Yes, Bhaiya.
Okay, so after doing question 15, can you okay, so in this question what we were supposed to do is we were supposed to tell what should be present in the sensitivity list. Okay, so as we saw, anything that is present on the right hand side, we have to place it in the sensitivity list, right? But so if something is on the right hand side, it means it is a form of input, right? And that needs to be placed on the sensitivity list. Okay, so the answer to question number 6 is all the input signals of a combinational block, it needs to be placed on the sensitivity list. And what will happen if we don't place it on the sensitivity list is, if we are planning for any particular desired response from a digital circuit, so if any of the input is not placed on the sensitivity list, then what can happen is, instead of a combinational logic, it may synthesize a sequential block, it can synthesize a latch. Okay, it is because like whenever, let's say there is a variable called a, I haven't placed it in sensitivity list, so the code won't monitor when that is being changed, when a is being changed. And what will happen is, if a somehow gets a value of 1, it will stay as 1. So that's basically a sequential logic, right? It retains the memory, and the overall functionality of the circuit will also go bad. So we need to ensure that all the input signals of the combinational logic, it is present on the sensitivity list. So these were the questions that we covered in today's live session. So Do you have any query in any of the questions?
Bhaiya, in question number 5, you describe about the behavior. I mean, here the behavior represents any operation performed by that circuit or something like that.
Correct.
Okay, okay, then. Thank you, Bhaiya. Thank you
Yeah.
so much.
Okay.